Welcome, cosmic explorers, to Space. Today, we're diving deep into the fascinating world of astrobiology. Have you ever gazed up at the night sky and wondered, are we alone in the universe? Well, you're not alone in that curiosity. In fact, there's an entire scientific field dedicated to answering this very question. So buckle up as we embark on an extraordinary journey through Astrobiology 101, the hunt for life beyond Earth. Imagine for a moment that you're an astronaut, floating in the vast expanse of space. As you look back at our pale blue dot, Earth, you can't help but wonder, could there be other worlds out there teeming with life? This question has captivated humanity for centuries, but it's only in recent decades that we've developed the tools and knowledge to seriously pursue the answer. Astrobiology is the study of the origin, evolution, and distribution of life in the universe. It's a field that combines biology, chemistry, physics, astronomy, and even philosophy to tackle some of the most profound questions we can ask. But before we launch into the depths of space, let's start with the basics right here on Earth. Life as we know it requires a few key ingredients: liquid water, organic compounds, and energy. Earth is the perfect example of a planet that has all three in abundance. But here's the kicker. We've only found life on one planet so far. Ours. Does this mean we're alone? Not necessarily. It just means we need to look harder and smarter. Now let's zoom out and consider our cosmic neighborhood. Our solar system is home to several tantalizing possibilities for life beyond Earth. Mars, once thought to be a dead, dusty world, has surprised us time and time again. We've discovered evidence of ancient riverbeds, seasonal flows of liquid water, and organic molecules in its soil. While we haven't found any little green men, the red planet remains one of our best bets for finding microbial life, past or present. But Mars isn't the only game in town. Jupiter's moon Europa and Saturn's moon Enceladus both harbor vast oceans beneath their icy crusts. These liquid water environments, heated by tidal forces, could potentially support life forms similar to those found in Earth's deep-sea hydrothermal vents. Imagine creatures swimming in alien seas, completely unaware of the universe beyond their icy ceiling. Now, I know what you're thinking, but what about aliens? You know, the kind we see in movies. Well, while Hollywood's depictions are entertaining, the reality of extraterrestrial life might be far stranger, and perhaps more fascinating. The truth is, we don't know what alien life might look like. It could be as simple as bacteria, or as complex as a civilization far beyond our comprehension. But here's where it gets really mind-bending. The universe is unimaginably vast. Our Milky Way galaxy alone contains hundreds of billions of stars, and many of those stars host planets. And that's just one galaxy among billions in the observable universe. The sheer numbers suggest that the conditions for life must exist elsewhere. But if that's the case, why haven't we found it yet? This conundrum is known as the Fermi Paradox, named after physicist Enrico Fermi. It asks, if the universe is so big and so old, where is everybody? There are many proposed solutions to this paradox. Perhaps intelligent life is rare. Maybe civilizations tend to destroy themselves before they can spread across the stars. Or perhaps we're simply not looking in the right places or in the right ways. This brings us to one of the most exciting frontiers in astrobiology, the search for exoplanets. These are planets orbiting stars other than our sun, and in the past few decades, we've discovered thousands of them. Some of these worlds exist in the Goldilocks zone of their stars, not too hot, not too cold, but just right for liquid water to exist on the surface. One such planet is Proxima Centauri b, orbiting our nearest stellar neighbor. At just 4.2 light-years away, it's practically in our backyard in cosmic terms. While we can't yet directly observe its surface, models suggest it could potentially support life. But here's the catch. Proxima Centauri is a red dwarf star, much smaller and cooler than our sun. Planets orbiting these stars face unique challenges, like intense stellar flares and tidal locking, where one side of the planet always faces the star. Could life adapt to such extreme conditions? On Earth, we've found organisms thriving in some of the most inhospitable environments imaginable, from scalding hot springs to the freezing depths of Antarctic lakes. Life, it seems, is incredibly resilient and adaptable. But how do we actually search for life on these distant worlds? One method is to look for biosignatures, telltale signs of biological activity in a planet's atmosphere. For example, the presence of both oxygen and methane in an atmosphere could indicate the presence of life, as these gases quickly react with each other and must be constantly replenished to coexist. Upcoming missions and telescopes, like the James Webb Space Telescope, are designed to peer into the atmospheres of exoplanets. They'll be looking for these biosignatures, potentially giving us the first evidence of life beyond Earth. Imagine the day when we announce to the world that we're not alone in the universe. It would be one of the most profound discoveries in human history. But what if life out there is so different from what we know that we can't even recognize it? This is where the concept of weird life comes in. Scientists are exploring the possibility of life based on different biochemistries. Could there be organisms that use something other than DNA to store genetic information? Or life that uses a solvent other than water, like the methane lakes on Saturn's moon Titan? These questions push the boundaries of our imagination and challenge our very definition of life. And that's exactly what makes astrobiology so exciting. It forces us to question our assumptions and think outside the box, or rather, outside the planet. Now let's talk about one of the most intriguing methods in the search for extraterrestrial intelligence, SETI, or the search for extraterrestrial intelligence. SETI researchers use powerful radio telescopes to scan the sky for artificial signals that could indicate the presence of advanced civilizations. So far, we haven't picked up any alien radio shows or intergalactic podcasts, but the search continues. But here's a thought-provoking question. What if we do detect a signal? How would we respond? This isn't just a scientific question, but a philosophical and ethical one as well. Should we reply? What should we say? And who gets to make that decision for all of humanity? These questions highlight an important aspect of astrobiology. It's not just about science, but about our place in the cosmos. It touches on deep philosophical questions about the nature of life, intelligence, and our role in the universe. Now let's bring it back down to Earth for a moment. You might be wondering, why should we care about life on other planets when we have so many problems here on Earth? It's a fair question, but here's the thing. Astrobiology isn't just about looking outward, it's also about looking inward. By studying the potential for life elsewhere, we gain a deeper understanding of life here on Earth. For example, astrobiologists study extremophiles, organisms that thrive in extreme environments on Earth. These studies not only help us understand the limits of life, but also have practical applications. Enzymes from heat-loving bacteria are used in DNA testing kits, and organisms that can survive in highly saline environments are being studied for their potential in sustainable agriculture. Moreover, the search for life beyond Earth gives us perspective. It reminds us of the preciousness and fragility of our own planet. As we scan the cosmos for other habitable worlds, we're reminded of how rare and special our own planet is. This realization could inspire us to take better care of our cosmic home. But let's zoom back out to the big picture. The quest to find life beyond Earth is more than just a scientific endeavor. It's a journey of self-discovery for our entire species. Each new discovery, each tantalizing hint of potential life out there, reshapes our understanding of our place in the universe. Imagine the day when we finally discover microbial life on Mars or beneath the ice of Europa. Or picture the moment when we detect an unambiguous signal from an alien civilization. How would these discoveries change us? How would they alter our perspective on life, on our planet, on ourselves? These are the questions that drive astrobiologists forward. They push us to develop new technologies, to launch ambitious space missions, and to peer ever deeper into the cosmos. And with each step forward, we expand the frontier of human knowledge and push the boundaries of what's possible. But here's the thing. We don't have to wait for these groundbreaking discoveries to be inspired by astrobiology. The very act of searching, of asking these big questions, is transformative in itself. It reminds us of our common humanity, of our shared wonder at the mysteries of the universe. As we wrap up our journey through Astrobiology 101, I want you to take a moment to look up at the night sky. Each of those twinkling points of light could be a star with its own family of planets. And on one of those distant worlds, there might be someone or something looking back, asking the same questions we are. We stand at an incredible moment in human history. We have the tools, the knowledge, and the curiosity to seriously pursue the question of whether we're alone in the universe. And regardless of what we find, the journey itself is transforming us, expanding our understanding of life and our place in the cosmos. So what do you think? Are we alone in the universe? Or is life out there, waiting to be discovered? The answer might be out there, hidden in the atmosphere of a distant exoplanet, buried beneath the ice of a moon in our own solar system, or encoded in a signal from the depths of space. And who knows, maybe you'll be the one to make that world-changing discovery. As we end this cosmic journey, I want to leave you with a thought. Carl Sagan once said, "Somewhere, something incredible is waiting to be known." In the vast, mysterious realm of astrobiology, that something could be the discovery that changes everything. So keep looking up, keep asking questions, and keep exploring. Because in the end, the greatest frontier isn't just out there in space. It's in our relentless curiosity, our unwavering spirit of exploration, and our boundless capacity for wonder. Thank you for joining us on Space for this exploration of Astrobiology 101, the hunt for life beyond Earth. If you enjoyed this cosmic journey, don't forget to like, comment, and subscribe for more out-of-this-world content. Until next time, keep wondering, keep exploring, and remember, the universe is out there, waiting for us to discover its secrets. This is Space, signing off.